Rover3 is a context management system that manages relevant information for any situation. The goal of the system is to provide relevant information to users or systems for a given situation by managing what information would be considered relevant. Using ontologies as a methodology to model information, users can model generic situations that comprise entities, attributes, relationships, and actions one can take. Implementing the concept of a dynamic ontology through the use of ADIM, or Automatic and Dynamic Information Model, an ontology author can encode relevance into the model. As a result, Rover3 manages the instantiated model and ensures it evolves as deemed relevant. As ontologies can be vast and include all possible relationships for any number of entities, the consumer of an ontology is left to decide what portions of the model are relevant for any one given situation. ADIM grammar directs Rover3 which relevant subset of the ontological model should be instantiated and involved as a situation is both created and information is realized. Rover3 is a web-based service with two data stores. Each data store is a Neo4j graph database, one of which contains the ontological models, and the other which holds the instantiated situations and activities that can be used to help resolve the situation. Models are created using the Neo4j cipher language. The ADIM grammar is embedded in the models and allow models to expand, contrast, enrich information, and track actions in an effort to assist users in reaching the goal for the given situation. To see this in action, let's look at a demo of Rover3. In this demo, we will show how Rover3 uses an ADIM dynamic ontology to instantiate two different situations. We will also populate the models with simulated real-world information and observe how the relevant information model evolves within the context store. We start by observing the ontology. Note as we navigate, if we hover over a node or relationship, attributes and properties about those primitives actually show on the bottom of the screen. We've modeled three situations in this ontological store. We have a generic car accident, of which a person is a first responder to, with some activities, as well as a more specific two-car accident. The two-car accident has two cars involved with it. The cars, much like the individual people, are quite simple in that they don't have many attributes, but rather they are instantiations of a more specific ontological model that has lots of attributes. If we look at the car ontology root, we see ADIM grammar as one of the attributes. The precache tag tells Rover3 to enrich data when other information has been acquired. The person ontology is similar. It does not have any ADIM grammar, but it has a collection of attributes that we should acquire whenever we're working with a person within the context store. The person ontology, though, has a few other relationships about it. Personal information is a thing a person can have. As there is no ADIM grammar in the relationship or the entity, this entity is always considered relevant. A person's profession, however, is relevant when a job interview exists. And this is seen by the situation exists term. Similar, health records are only considered relevant if an accident exists. We also have an activity that is not associated with a situation, but rather the existence of an entity and an attribute with a particular value. This activity would be instantiated and considered relevant if an activity was considered stolen. Let's actually create a situation. We go to the web browser and create a two-car accident. Rover3 will now look through the ontological store and create in the context store a model of a two-car accident, pulling things from the general ontological store, items that are relevant, and pruning things that are not relevant. The context store, which was once empty, now has the accident. We've instantiated the car accident with its activities and the components of the two-car accident. This is because the two-car accident is a more specific example of the car accident. So we want to work off the associated activity with the car accident. The people, all alike, have personal records because this is default. This is by default always relevant. But we've also instantiated health records. We now have a nice framework where users of this information can start enriching the information that or start populating this model with the information that they find. And this can guide them to gather the appropriate information relevant to the situation. As we start to acquire information about this particular situation, we can enter it into Rover. In this example, we found the license plate for the one car. So we tell Rover to assign this value to that attribute. Coming back to the context store, we note a couple things. Car 2, which is the one that we updated, now has the license plate listed. But the isStolen attribute has also been updated. The pre-cache tag for cars tells Rover3 to go out and query the database. We see that it is stolen. We also instantiated an arrest activity because this car is stolen. So the simple act of placing one piece of information about this real-world situation has expanded the relevance model. It has also enriched additional attributes about entities that we consider relevant. If we wanted to create a second situation, we could do so. Here we're creating a job interview. Like the two-car accident, Rover3 is instantiating all components of the ontological store that would be considered relevant for this situation. We have our job interview and the two people associated with the job interview, each of which have personal records, yet this time we only have professional records. That's because it is a different situation involving generic people.